This is the second part of the review for the quadratics. For this, I'll be looking at the back side of the review, which for the most part is just the graphical type things that we'll have. All right, before I actually start, question 5 and 6, you're going to be asked to identify a lot of things that are about the graphs, and as I go through it, there isn't necessarily a strong connection with how the problem starts out versus the things that you'll be asked later, but it is more or less a variety of just stuff that we should be able to do. So if you're looking for a big theme here and a step-by-step process, it doesn't really quite apply to all the questions that you're going to get asked here. Okay, number 5, it starts off with wanting you to write the vertex form for the picture that you have here. This is the outline to the vertex form. Okay, one of the great things about it is that the h and the k value are right here in the picture. The vertex is given to you. That location is going to be at a 2 and a 5. Okay, so when that goes into the equation, the one thing that you have to be aware of is that when the 2 goes in for the h, which is where it goes, you have to make it look like the opposite. So this is going to show up as an x minus 2, even though in the picture it's a positive 2. So make sure that you can go back and forth and you know that we do have that change. The k value is the 5. That's exactly as is. Don't switch it. What we then need to figure out is our a value. So the a value, ways that you could go about it, the one you should really look for is just the shape of the graph and see if you can get it from there. But if you can't quite get it with that, what you could do is start to plug in x's and y's that you might know or locations. Like I could plug in this point. I could plug in a 1 and a 2. So I could plug a 1 here and make the whole thing equal 2 and then just solve for the a if it's necessary. But hopefully you can recognize some of the patterns, especially if it's a stretch, which is what we have here. So this, like moving to that point, because I'm going back 1 and down 3 versus the typical back 1 and like up or down 1, that means I got a scale factor of a 3 that's involved. So you're going to get a 3, but also because that it's opening down, you'll call it a negative 3. And again, if you can't get that from the picture or something's not working out, just grab a point, plug it in for the x and the y. All that is really easy to solve. You can plug in a 1, you're going to get negative 1 squared, which is 1. You're going to have the 5 that you can move over, and then just do a quick division and you're done. So consider that and maybe actually run through the numbers just for the heck of trying that as well. All right, Y-intercept. The one thing you need to be careful with vertex form is that you don't mistake this constant as being your Y-intercept. That is true for standard form, but this definitely is not the Y-intercept because it's the point that it's up here and not over there. All right, in this graph you cannot see the Y-intercept, so there's no freebies on that, but the Y-intercept is always when the x value is 0. So what we could do is plug that in where you see the x. So you're going to have negative 3. This will just be a negative 2 inside. Once you plug in the 0, that becomes a 4. The 4 multiplied by 3 is negative 12, plus the 5 is going to give you negative 7. So your Y-intercept is at, fix that up so it looks good, is going to be at 0, negative 7. Okay? The next 2 questions, we kind of switch into a different topic. We're going to ask about the focus and the directrix that go with this. I'll give you a caution right now that not in all the problems do they work out to be like great locations, and this will be one of them. But the idea behind how to do it should be defined. You can apply that on the test. Okay, the focus is going to be inside the parabola, maybe around here. That's all a little bit tough to figure out, but it is inside of it, and it's going to be underneath the vertex. The directrix is going to be a line that's above it. So just kind of getting your bearings straight on like those locations. Okay, this, like if you have a shift away from the origin, which we're way up here, not at the origin, you could use this as an equation that will find out where these places are. Okay, so the focus, that point, what you really need to try and find is the p-value that goes from the vertex out in both directions. And in the notes we would have talked about the p-value being equal to 1 over 4 times a, where a is taken from the equation. In our case, it's the negative 3. Okay, so using this, I guess, first as a formula, we can take that negative 3 and we can multiply it by the 4. So let's say I got my k plus 1 over 4a. That's going to become, and actually let me go ahead and plug in the k as well. The k is your y-intercept. not your y-intercept, your y value from the vertex. So it tells you where you're positioned at right now. When you add on the 1 over 4a, which is going to be 1 over 4 times negative 3, that's going to offset you in the direction where the focus should be. Now, being that this turns out to be a negative 1/12 that you get from here, it's actually going to drop it down, which is going to move you to the correct location here. Okay, so the 1/12 is not a nice number to work with. For at least like this review, what you could call it would be 4 11/12. You could go with that. The decimal isn't really that nice. Okay, so we're looking for the focus. It's a coordinate. It is going to be in line with the vertex, the axis of symmetry. So it's going to be at a 2, and then the height is going to be the 4 11/12. Now for the test, hopefully that'll turn out to be a whole value, so it's a little bit nicer to work with. But that's literally the worst case you could get. Okay, now on the flip side here, the Directrix is going to be that 1/12 up. So you don't even really need to do the whole formula. You can just start with the 5, and you can add on the 1/12, which is going to be 5 1/12. Okay, and the Directrix is a line, so its equation is going to be y equals, being horizontal, it's going to be y equals 5/12. Okay, and not always the nicest thing to have a mixed number when you're writing things up, but it works. That's what it is, and again, hopefully you'll get a whole number, and that's